In 1654, a prominent physician in Florence placed a glass tube against the chest of a dying patient. The liquid inside rose, marking a level on a piece of paper. The doctor glanced at it, nodded, and prescribed a bleeding. He was completely wrong about the treatment, and the number on that paper was entirely useless. It would take another 2 centuries, thousands of failed experiments, and bitter rivalries before humanity finally agreed on how to measure heat. This was the birth of the thermometer. But the true story begins 2,000 years earlier, in the shadows of ancient Greece. Around 250 years before Christ, in the bustling Greek city of Byzantium, an engineer named Philo was staring at a pot of water. Philo was not trying to measure heat. He was trying to understand the invisible. He took a hollow sphere made of lead, connected it to a tube, and submerged the open end of that tube into a jug of water. When he placed the sphere in the bright sun, the air inside the sphere expanded. It pushed the water down in the jug, forcing the liquid to travel up the tube. When he moved the sphere into the shade, the air contracted. The water level in the tube dropped. Philo had accidentally created the very first thermoscope. He did not know what heat was. He did not know what air pressure was. He just knew that temperature moved liquids. And he was not alone. In the 1st century of the modern era, a brilliant Alexandrian mathematician named Hero took this concept and expanded it. Hero built elaborate temples where the heat of the morning sun would cause hidden mechanisms to pump water, open heavy doors, and make trumpets blow. To the worshippers, it was divine intervention. To Hero, it was physics. But here is the crucial detail. Neither Philo nor Hero had a scale. They had no numbers. They could see that the water moved more on a hotter day, but they could not say exactly how much hotter. It was a parlor trick, an engineering marvel that could tell you if today was warmer than yesterday, but not by how much. They possessed the glass. They possessed the concept, but the idea of assigning a number to warmth simply did not exist in their minds. It was an intellectual bridge they never crossed. And humanity was about to fall into 1,000 years of darkness, leaving that fragile glass sphere completely forgotten. The idea slept for over a millennium. It woke up in the late 16th century, in the wealthy, powerful Republic of Venice. The Venetians were the undisputed masters of glass. Their secret was the local sand, the intense heat of their furnaces, and a monopoly they protected with lethal force. This unparalleled mastery of glass allowed an unknown glassblower, working alongside brilliant minds, to create something revolutionary. They took Philo's concept, inverted it, and sealed the liquid inside the glass. Instead of using water, which evaporated and froze, they experimented with spirits of wine, alcohol. It expanded rapidly, it remained liquid in cold weather, and it was clear. For the first time in human history, the measurement of temperature was trapped inside a portable, sealed tube. The man most often credited with refining this device was Galileo Galilei, though historians still debate the exact extent of his involvement. Galileo was part of an elite circle of intellectuals in Venice, and he used his thermoscope to study the heavens and the seasons. But he had a problem. The Venetian thermoscopes were beautiful, but they were liars. If you took one out of a room and put it in the square, the sun would hit the glass and the liquid would rise. But if a storm rolled in, the dropping atmospheric pressure would also make the liquid rise, even if the temperature was getting colder. They were measuring heat and air pressure at the same time, and there was no way to separate the two. Still, the wealthy elite had to have them. Grand Duke Ferdinand II of Tuscany became obsessed with these instruments. He funded a workshop to produce them, enclosing the liquid in sealed glass tubes with tiny glass bulbs at the bottom. He handed them out to foreign dignitaries like they were magical amulets. It was the ultimate status symbol of the Renaissance, but they were still fundamentally broken. In the early 17th century, these beautiful but flawed instruments began to travel across Europe. A Venetian thermoscope in the hands of an English lord was a conversation piece, but to a scientist, it was a nightmare. The most brilliant minds of the 17th century realized that without a universal scale, they were just looking at liquid going up and down. A doctor in Rome would record a high temperature, while a doctor in London would record a low one, even if the weather was exactly the same. They needed numbers. In 1612, an Italian physician named Santorio decided to fix this. He took a thermoscope and scratched tiny marks along the glass tube. He placed it in the snow and made a mark. He placed it over a candle flame and made another mark. Then he divided the space between them into equal parts. This was the first true thermometer. But Santorio was a doctor, and he had a specific goal. He wanted to measure the heat of the human body. He built elaborate contraptions where a patient would hold the bulb in their mouth or place their hand on it while he watched the liquid climb his arbitrary scale. He was the first person to try and quantify a fever. This decision seemed small at the time. It was not. By trying to measure human heat, Santorio introduced a weapon in the war against disease. But his scale was entirely his own. When he died, his numbers died with him. Throughout the 17th and 18th centuries, the medical establishment rejected the thermometer with astonishing arrogance. Doctors did not trust glass tubes. They trusted their own hands. A physician's status in society was built on his refined sense of touch. He would walk into a room, place his hand on the patient's forehead, and declare the fever hot, very hot, or burning. To rely on a machine was seen as an insult to a doctor's skill. The thermometer was viewed as a toy, a distraction used by fringe scientists. The medical establishment did not just ignore the instrument. They mocked it. Furthermore, the early thermometers used toxic substances. Some inventors, frustrated by the sluggish movement of alcohol, turned to mercury. Mercury is a terrifying liquid metal. It expands evenly and does not freeze, making it perfect for scales. But it is a deadly poison. The doctors who did try to use these early instruments risked breaking the glass and exposing their patients to severe poisoning. The superstition was not entirely unwarranted. It did not last. By the dawn of the 18th century, the scientific community knew they needed a standard. They needed fixed points. In 1701, a Danish astronomer named Ole Rømer was studying the stars in Copenhagen. He needed a way to record the temperature of the night air to perfect his telescopic lenses. Rømer devised a scale. He set 0 as the temperature of a mixture of ice and salt, which was the lowest temperature he could create in his laboratory. He set 60 as the boiling point of water. It was a strange, arbitrary system, but it caught the eye of a Polish instrument maker living in Amsterdam. His name was Daniel Gabriel Fahrenheit. Fahrenheit was an orphan, a merchant who had survived a poison attack that left him temporarily blind. He dedicated his life to precision. He visited Rømer, studied his scale, and decided it was too complicated. Fahrenheit multiplied Rømer's numbers by 4, adjusting the scale so that water freezes at 32 and boils at 212. Why these numbers? Because Fahrenheit was obsessed with the human body. He calibrated his scale so that a healthy human body temperature would land at exactly 96. He placed the thermometer under the armpit of a healthy man, marked the line, and built his entire mathematical universe around it. His instruments were flawless. He invented a way to clean mercury so thoroughly that it would not stick to the glass. His thermometers were suddenly consistent. If a Fahrenheit thermometer read 50 in Amsterdam, it read 50 in London. This was a revolution. But the world was not done fighting. Decades later, a Swedish astronomer named Anders Celsius decided Fahrenheit's scale was too messy. He created a scale where 0 was the boiling point of water, and 100 was the freezing point. It was upside down. When Celsius died, his colleague Carl Linnaeus flipped the numbers, creating the scale we use today. And here is where the history gets dark. Even with these perfect, calibrated scales, doctors still refused to use them. For another century, mothers watched their children burn with fever, and doctors simply felt their foreheads, guessing at the severity of the illness. Thousands died because the medical elite refused to trust a number over their own egos. If you are finding this history interesting, subscribe to the channel. Here at Common Lore, we tell stories like this every week, and you will not want to miss what comes next. The eventual acceptance of the thermometer did not just change medicine. It changed the map of the world. In the mid-19th century, a German physician named Karl Wunderlich finally forced the medical world to listen. He collected over 1 million temperature readings from 25,000 patients. He established that the normal human body temperature is 37 degrees Celsius, or 98.6 Fahrenheit. He proved that a fever was not just a feeling, but a specific, measurable physical event that followed predictable curves. This single piece of data revolutionized diagnostics. A doctor could now track the exact progression of a disease. But the impact reached far beyond the sickbed. The thermometer reshaped global industry. In the 18th century, a French scientist discovered that the boiling point of water changes depending on altitude. The higher you go, the lower the boiling point. This meant a thermometer could act as an altimeter. Explorers used sealed tubes of boiling water to map mountains and valleys that had never been charted. It allowed engineers to build the transcontinental railways, calculating the exact temperatures needed to forge steel that would not shatter in the winter cold. It dictated global trade. A shipment of wine from Portugal to England would spoil if the hold dropped below a certain temperature. The thermometer allowed merchants to track the climate of their cargo, transforming the economics of international shipping. It was no longer a glass tube. It was a compass for the physical world. The transition from fragile glass instruments to modern digital readers was driven by the relentless demands of the 20th century. Today, the measurement of temperature is an invisible backbone of modern civilization. We produce billions of thermometers every year. They are microscopic. They are in your phone, preventing the battery from overheating. They are in your car engine, your refrigerator, and your home thermostat. The global market for temperature sensors is worth billions of dollars annually, and this is the part that catches people off guard. The technology that started with water in a jug is now measuring the edge of the solar system. When the Voyager probes were launched in 1977, they carried highly advanced thermometers to measure the intense cold of deep space, hundreds of degrees below zero. When you take a COVID test, the tiny liquid line is a direct descendant of Santorio's first fever scale. In modern medicine, we no longer rely on a doctor placing a hand on a forehead. We use infrared scanners that measure the heat radiating from your body at the speed of light. The precision we demand today would have been unimaginable to Galileo. We measure temperatures to fractions of a degree, a level of accuracy that determines whether a chemical factory explodes, whether a vaccine remains effective, or whether a satellite survives the brutal heat of atmospheric re-entry. The world runs on a delicate balance of heat, and we finally know exactly what that heat is. Think about that for a second. In 1654, a doctor in Florence held a piece of glass trying to read a number that was completely meaningless. He guessed. He failed. That moment, that intersection of human frailty and scientific ambition, was the true origin of the thermometer. It was ignored for 1,000 years. It was treated as a toy by royalty. It was rejected by arrogant doctors. It frustrated astronomers, drove merchants to bankruptcy, and killed patients who needed precise care. It took 2,000 years of human history to take a piece of glass, fill it with liquid, and agree on what the marks on the side actually meant. Today, when you feel a chill, or when a child looks pale, you reach into the medicine cabinet. You pull out a small, quiet instrument. You wait for a beep, and in a few seconds, you hold a single number. A number that took 2 millennia of genius, error, and obsession to finally get right. If this story surprised you, subscribe to Common Lore and tell us in the comments which part of the history of the thermometer surprised you the most. And leave your like so more people can find this video.